Right, well, I've been talking to myself for 15 minutes, so we've come back with actually a memory card in the thingy console, and we've got a Binatone 5-star which belongs to a customer. And the first thing I did when I took the lid off, I noticed the speaker leads are corroded to some extent, and the capacitor actually fell out of it, which is here. But it's not come off the printed circuit board. And then we've got this bizarre capacitor on the extension speaker socket. Well, all that would do is to turn the entire content to a muffled mumble. What I did find was this capacitor, once changing, I can see that the thing is the sleeving is migrating. So we'll put a new capacitor in there. It's 220 microfarads. So actually it looks like it's leaked some of its stuff. Yeah. So I don't know whether there's audio issues and it's because of this capacitor needing replacing, and that's why somebody's done that bodgery. I don't know. Bit of corrosion on the bottom of the board. So I was going to do this today. It's Tuesday. I've run out of time because I started it. I was going to put 15 minutes into it this morning, and I did, and didn't record it. So the fault, according to the customer, is no transmit. And see whether we can rectify that. I'm just going to look at this for dodgy dry joints, and there's quite a few on this. Not because I suffer from the dry joints, but because it's been in a damp environment at some point. Mind you, if you left it in a car for 40 years, that'd be a jolly damp environment. Some of these are around the transmitter, so it could be easily be what the issue is. I mean, as I've said before, I regard the Binatone 5-star as the best UK 2781 set of all time. Bit of a garish front panel, but so although we get superb performance out of some York 863s, we seem to consistently get excellent performance from these, as we do with the SMC Oscar 1. And I can't say I've had a substandard Harvard 420M either, so there you are. I've had some very mediocre Rotail 240s. Not faulty, just mediocre. So at the end I'll go over, well, I'm only going to do 15 minutes today on this. And then I'll do the isopropyl alcohol on this before I put it to bed. Right, well, I feel happy I can switch that on, but not till I've removed this capacitor, which has corrosion on it anyway. I'm not sure why somebody would do that. I'll snip off the other end. Perhaps it's a modification, you get 1,000,000 watts out of the radio if you have that. Right, so I've done the dodgy capacitor. So if I can find the power connector, it's come with a power connector, but I'm not sure that the one it's come with, I'm not sure if it is man enough for the job. I've got a heavy duty one here on the bench. If I show you what's come in, I don't even know where I put it now, but we'll do that comparison. Oh, it's here. So that is the power lead that's come in with it, and this is our. These are ones we buy in and sell, but I'm more likely to be able to take. I'm aiming at. Although the radio isn't going to draw 1.6 amps maximum, I just feel that this wire would be hard push to do that. I'll tell you what, we'll do some comparisons with this power lead when we've tuned it up on our power lead. That would be an interesting little test. It's like we did with the walkie-talkie a few days ago, and it was at 1.6 on the lead supplied, 1.6 watts, and 3.2 watts on our lead. So right, we'll connect it to our crocodile clips. I've been working on the amplifier for the Binatone record player that Andy at Stockport has done the turntable for. That's all done as far as I'm concerned. So we are powered up as far as the power supply goes. Let's get that plugged into there. I'll do the extension speaker rather than the test equipment in case there's a malfunction. It's the only set I'm aware that you switch the extension speaker on from the back, at the back from the front. There we go. Track 20, that's off, that's in CB. It's in high power. We want external speaker, and we actually want a mic plugging in. So here's our standard Cybernet mic. It has come with the factory original mic, but we're going to run with test mic. That's making the right noise. Just plug into the other socket, switch to PA.
Testing 1 2 3 1 2 3.
Right, well that's that done, isn't it? Let's see what we can tick off already. Or is it the 14th today? I've put the 14th. This gentleman is an end user. He asked nicely and he's receiving. Meter lamp works, and the sockets all work, the PA works. And that's all we can say at the moment. Right, we'll go back to CB. Turn down the volume so as not to annoy anybody. For some reason I haven't got picture in picture. Right, well we haven't got transmit, just as he says. I think the first thing to do is to check the VCO. So we'll select channel 40. These don't have a TX light, so you're not going to be sure as to whether it's gone into transmit. Right, I'm just going to try and sort out picture in picture. Okay, so next day we have come to the conclusion that phase lock loop chip is failed. Has failed. Still got the temporary crystal there. You would think that if the crystal was open circuit because of it being corroded, then, well, you found the fault. But having gone through the normal things with the circuit diagram here, looking for the voltages, taking out some of the transistors in the buffer amplifier and the transmit switch and the VCO, and checking them and they're all okay, and things like that, I've come to the conclusion that we're going to have to change the phase lock loop chip, like it or not. So I'll just take another one out, and what I always do to make sure that the pins actually fit is to try and offer it up from the wrong side like that, which I have done, because it's quite difficult to get in the gap without a lot of dismantling. So I'll just install that right now, and hopefully we'll be rewarded. Right, having done that, we've now got a totally different set of voltages on the VCO. We've got 6 instead of wherever it was. So we've either got a short circuit, just going to transmit, see whether we can set the transmit VCO. Now something's not right there. What I've done along the way, and this is why it's taken a lot of time, I've changed all the... I've taken out and tested all the transistors. 1, 2, 3, 4, and the 2 switching one, all out. That one was lower gain than I would expect, and we've swapped it for one off a scrap chassis, but that wasn't the fault. But phase lock loop chip, I've changed that capacitor. There's an electrolytic capacitor as a precautionary thing. Where's my other glasses? So I don't like to do that because the phase lock loop chips are expensive. Oh, I can't even remember which one it was. That one down there, capacitor 4, where's capacitor 4? That's 3, 11, 4, there. So, because we've got some haywire voltages on the phase lock loop, but the thing about the phase lock loop is we've got the 10.24, so its internal oscillator is running. Anyway, that's the remains of the phase lock. Oh, it's now on the floor. I was going to show you the remains of the phase lock loop chip. That's the crystal with the leg that decided to have snapped off at some point. So the question to me, I have in my mind, is I wonder when this last worked. I don't know the story behind this radio. He's not told me, but it isn't. It certainly isn't something he was using till 2 weeks ago, and it suddenly stopped working. For the crystal to have got a corroded leg. So did the phase lock loop get zapped, and it's been left in a cupboard for 30 years? In a shed probably, because there's corrosion. What I'm going to do is put that crystal. We temporarily put a crystal on the back of the board in the hope that it was going to be okay, and it is okay. So we'll remove that. And seeing as it works with this set, we'll use this crystal. I'm going to because he's got an expensive part, there's nothing I can do about that. I'm going to let him have that crystal for nothing, simply because it was donated to me. But of course things are donated to me to help raise funds for our UHF repeater. So I can't always give everything away. I wonder where the solder sucker's gone. If this was a pantomime, you'd oh, it's there. You'd say it's behind you. I'll then go over all this again with isopropyl. Along the way, I also did a lot of dry joint stuff. That's coming away. I wanted to be absolutely certain that it was a faulty phase lock loop, and that's why I took those 6 transistors out. So I ended up swapping one, but to no improvement. But it was lower gain than the manufacturer's data says. So hopefully we'll not ruin this. This will have come off an illegal, probably a Comtron 4 or one of those naughty sets, which will have been donated to us for the purpose of parts. If I started charging this guy for every part, you know, I'll try and leave these. I'll put the sleeving back on, which is original to these. I've got the other leg. You know, when I come to put the speaker back on, I hope that works. So the thing is, he said no transmit, he didn't say no receive. So I just wondered if there just wasn't anybody about, and he just thought the FM hiss was the fact it was receiving, when in fact it wasn't. I'll hold that in position while we solder it. This would be just the point where I can't find the solder. Now I've got it all beautifully balanced. Now of course the trouble is, having soldered that, it's going to have transmitted some heat to the crystal. So if we try and set the frequency, because I don't know what condition that crystal's in, it's working, but I haven't tried aligning the frequencies. But as long as it's over 100, if it doesn't hit the 125, I'm not that bothered, especially when it's for free. I've got all my wires twazzled, that's the word. Put the set back on, do the tune up, and hopefully there's nothing else wrong with it. Well, we can hear the signal generator. That's on 100 microvolts. So we now need to go through this radio. I'll put the oscilloscope away, all things which I've used to verify. We need to do the VCO. So I'll put my crocodile clip on that earth strap. Right, so channel 40, here's receive. I've set it roughly, of course, in part of the fault finding, and I can't remember whether it's supposed to be 4 volts or whether it's supposed to be 3 volts because I've lost the plot. This is the best we ever had. Mikey M1 EMF, not a well man, but he did this, and it's so much clearer than the original. 4 volts, you see, I'd forgotten. Right, are we ready? Yes. Receive, 4 volts. Now, to some extent they're interactive between transmit and receive. Transmit, 4 volts. That's the trimmer. 4 volts. Back to receive. 4 volts. Your checksum is channel 1. And they want it to be between 1.8 and 2.5. So let's have a look on receive. It's 2.15, and on transmit it's 2.15. We can put that away. That's what we needed. Back to channel 20. Right. So we've done that. LC7137. So I'm not going to put nothing. I'd be silly putting nothing all the way down. I've fixed it, and then we're going to, without touching any of the alignment, we're going to see what it did work like last time it worked. So we've done the LC7137, we've done capacitor 4, and we've done capacitor whatever that is, I've forgotten, and 220 microfarads at 16 volt. I think that's 33 microfarads at 16 volt. I'm not going to charge him for those. You know, they're less than 50 pence each. I just hate it when that chip's failed, and of course on the Uniden ones it's irreplaceable. Though there is a firm in Brazil will sell you 100 at $29.99 each. I don't think we'd be able to sell any at $29.99, let alone get them shipped over. Here goes. Picture in picture on. Transmit. Oh dear, it's 5.5 watts. So that's the next thing to address, is it? Sorry, 4.5. It's probably bounced so much static, it's zapped the phase lock loop. .2, 4.4. Clap, clap, clap. Weren't they clever? Oh, low powers. 15 milliwatts. Now, as a precautionary thing, I'll just spray the preset and waggle that around, and then when we come back, that hopefully is ready. Transmit current at the moment on full power got to be very quick on this because I've got Mr. Gibbons doing on the air test. It's 1.246, which is actually very reasonable. Deviation on this test set, wallow. Have I got no, or have I got me off tune? Testing 1 2, testing 1 2, wallow. Right. We've got mic gain down. Nope. Wallow. Wallow. Got. It's ridiculously low. Let's go on the other scale. Wallow. That's the 0.5 scale, so it's 0.2. Right, we'll do the frequency. Camera 2. Why isn't camera 2 responding? Of course, camera 2's camera. Because camera 2 has moved. Put camera 1 in camera 2's position. I just haven't got time because this has got to be on the air tested. Oh, look at that! So of course it was nil before. I will do that because the crystal was broken. We'll see whether we can get that final. That's lower. There we go, spot on. 27,79125. So that was nil, and it's now 4 plus 4. So when we key up, the RF meter does what? It goes to 5, which is probably right because it's doing 4.5 watts. On receive I've got 100 microvolts on, so we should be showing exactly S9, and it's pretty close. It's 71 microvolts instead of 100, so that's good. That was demodified. Demodify socket. Receive. Go. I don't know how we're going to respond if all these cameras have moved. I'll use the same camera. We'll kind of, because I can move this one around. No. Do you remember the golden shot? Left a bit, up a bit, down a bit, fire. Not had a telly since 2000. Right, SINAD. Well, a bit more volume. Making sure RF gain's in the correct position. And we need to go over to the SINAD, to the instruments, because at the moment we've just got the speaker on the wall plugged in. I don't want to put, you know, sometimes you can get power going up the speaker or something because of a malfunction. I don't want to damage the test gear. Put an earth on there because it's floating. Something's dirty. There we are. Very good. 0.29. It's going to be one of those unless I fix it worse. 0.45. Squelch. Want it to be 100 microvolts. Put the I don't think we can move these cameras around. It's all... No. I'll move that one manually as well. Something's moved. That's the attenuator anyway. So I want it to open at 100 microvolts. So 1, 3, 10, 30, 100. It doesn't. In fact, it never ever opens. It's one of those squelchers. So never opens. I can move the IF out, so it can just be out of adjustment. Because I think the phrase is farted with. Yeah, it's lousy. Minimum squelch sensitivity is 1.2 microvolts. Okay. So we'll go through the transmitter. So, as I said, it's doing 4.5 watts on channel 20, which is going to melt the... I'm going to have to do this one on one camera. We've done frequency, we don't have to go back to that. Oh, and unplug the extension speaker. We can switch it off, can't you, on these? There we are. Okay, so we want to get a peak. So although it's over the power, it still needs to be peaked because it may be not balanced. So centre of peak, that looks like it was right. That wasn't right. Of course, power's dropping because it's overheating. And which tool shall we? I think we can use the green one. So it's peak. That was at peak. Peak. That was at peak. Peak. That was at peak. So the plonker's gone and left it in what we call service mode. Oh, I've tuned it up. Well, you melt these 4 coils because it's not intended to do that. So the service manual says this radio does 3.8 watts. We set them to 4, and we're not going to stretch it beyond that because it will melt those 4 coils. As it happens, they haven't melted, so I'm presuming it didn't get a lot of use by the time it zapped the phase lock loop chip, whatever happened there. So we need to now turn the yellow one clockwise so that we just are at 4.4, which is there, and then we need to turn that anti-clockwise for 4, which is there. I might have to come back to this because it may be hotter than it's supposed to be. So channel 40, I've got 3.95. Channel 1, I've got 4. So I mean that's balanced right. So what current consumption we now got? 1.04. That's better, isn't it? Low power. We'll find the switch. Let's see if this will adjust to whether we've got a faulty preset. we have to change that. Oh, I don't know. I'm trying to keep costs down. We can set it to, see if it returns to that. Yeah, it does. 400 milliwatts. So, I don't know if the switch needs cleaning. I think the switch needs cleaning. Count it in from the third from that end. That's more promising. Right, that's that done. Set the meter. So it now needs to say 4 watts into our dummy load. That's the adjustment for it. And it wasn't far out. There. Right, let's do the deviation because something's not right there. And is this what all these capacitors messing about are? I don't know. We need to get that one to its center position. Put that away. And we'll plug into our other test set. Just check the deviation. Because what did I say? 0.2 I was reading. Doesn't look like the receiver's being fiddled with on this, which is good. Wow, it is 0.25. So we've either got a fault. Wow, yeah, we've got a fault. Right, well, we'll have to come back to that. Now, Mr. Chippy's not here this weekend, so this will end up being tested on Monday. But there we are. Just check we've got RF gain in the right position. We have. Just check with the extension speaker on the wall that the PA is adjusting properly. Where are we? PA.
Testing 1 2, testing 1 2, testing 1 2.
That one.
Testing 1 2, testing 1 2, testing 1 2.
Yeah, so that's adjusting properly. Back to the deviation meter on our normal test set. 1 2 1 2. Wallow, 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 wallow. We've got a fault in the transmitter on that. Right, so that's we'll have to come back to that. Can be the varicap diode, because we've got good audio into public address, so you know that the speech processor, the chip here uses a speech processor. Half of that is used, is only half of it's used in PA, and the other half is used as well when you're into transmit mode. But basically, once it comes out of there isn't a lot between there and the varicap diode, which is in the wax department. So it's usually the varicap diode that's failed, but there could be a capacitor which can short the rail out. But we'll have a look at. Oh, I've switched the speaker off, haven't I? That's it. Right, we'll do the receiver. So the receiver was working well, but we need to see whether it's actually right. So I'll have to move this one camera around. Oscilloscope. Decent sized trace. Check the detector. Fingers crossed. Spot on. That's nice. I think we're going to do the IFs next. I want to be able to see the meter and at the same time see the SINAD meter, which I'm going to show you. I am. At the same time I want to look at the meter on the front because you can end up with the wrong peak. So we've got three coils I want to adjust. So we're looking at the SINAD meter. That needed adjusting. Drop the signal down. That needed adjusting too. And then the one under the wiring, you always hope the phantom adjuster hasn't twiddled this one. No, that was spot on. Okay, so that's the IF, and that could be why the squelch was lousy. So now go to the front end. That's under the wiring. That might not have got fiddled with. That's brought it up. That was spot on. And that was spot on. So that needed adjusting, the one under the wiring. Spot on, needed adjusting, needing adjusting, hidden one, spot on, detector spot on. So see if we get a new signal, a new reading on the SINAD meter. I'm on the wrong scale. .23. .21. 0.39. Now, does the squelch work? So full squelch. Show you the attenuator. I go for a little walk with the camera. La di da di da di da. Across a bit and down a bit. Across a bit. Have I run out? No, it's there. So that's a 0, 1, 3, 10, 30, 100, it never opens. So that we'll do the preset. Now opens at 100 microvolts. So hopefully the sensitivity at the other end. Set the threshold on the radio. Signal generator on. 0.65 microvolts. Let's fix that. Meter. Pretty well spot on that, as I said before. It's that one. It's dirty, that. It's just twitching at the right point. There we are. Smooth off the speaker. Right, we've just got to get to the bottom of why we've got very low transmitted audio. So we'll have to bring back the circuit diagram. Have a quick look at what's happening there. So, our varicap somewhere applies the audio it's there, isn't it? Is it that one? No. It's that one. So if that capacitor was duff, 140, we'd be robbed of audio. I'll have to look on the computer and come back to you. Okay, we've got haywire voltages around the speech processor chip, so we'll get a new one of those fitted. Right folks, let's try that. So change the IC, so switch back on. Well, obviously that's it, isn't it? So we'll turn that off and we'll go back to the deviation meter. I think we'll start by seeing what this deviation meter has to say. Let's just move across to the... Where are we? Across a bit. That one. So we'll, even if this isn't going to be accurate, we'll find out and be able to adjust it somewhere near. Well, according to that meter, that would be 2.5. We'll just double check it now. Now, what caused that to fail as well? So we've changed the phase lock loop chip. We've changed that chip. Has it been struck by lightning? At the other deviation meter. Wow, it's very slightly high. Wow, there we go. Right, well, we're going to do it. We're done as far as this set's gone. We are done. We haven't got time to put any lids on. I might just catch Mr. Chippy to doing on the air test. So it's is it 4558 speech audio preamp I'll put down. Right. So it's now 2.2 to 2.5 kilohertz and we're done. Wow. Oh, just take that off. Nothing else will be affected. We'll get that on an aerial. Just turn it off a second. I'm just intrigued as to whether the customer's lid works. And by that I mean speaker. You knew I meant speaker. So it's come with a mic. We haven't time to test that, I don't think. In fact, Mr. Chippy might not have time to do a test at all. So it may be after the weekend. So if that works, it's now connected. Internal speaker. No. Well, that was pretty predictable. I don't know what the customer's going to think about that, because I'm not sure where we're going to get another one of those speakers from. I think he's going to be running with external speaker, unless you all know where to get a 3.5 inch speaker, because they're not the 3s which these normally are. 3.5 inch at 2 watts. Right. I don't think it's worked on internal speaker for years. I don't think this has worked for 30 plus years. On low power. 1 nano Roger. Right, we'll prop that up. We'll do an on the air test and just loosely put the top lid on. Right, well, thank you for watching a very extensive repair with multiple faults.